Welcome back, everybody. Today we're going to be talking about finding roots and zeros after we factor quadratic trinomials. First, in order to solve, basically finding the roots and finding the zeros, basically the same things, two different terminologies. We've set a quadratic trinomial equal to 0, and we're going to use factoring to solve for it. First, we need to factor x squared minus 14x minus 32 equals 0. So I set up the factored form of it, x and x, and I ask what factors of negative 32 add up to negative 14. Well, there's lots of ways to get negative 32. We could take negative 2 times 16. We can take positive 2 times negative 16. But if I were to add those, notice what I get. Here I'll get a positive 14. And here I would get negative 14 because 2 plus negative 16 is negative 14. So there's my combo that works. Now we can think of this as two separate equations. Think of it as x plus 2 equals 0. Think of it as x minus 16 equals 0. Solving both of these for x, we get x to be negative 2 and x to be 16. Negative 2 and 16 are what we call the roots of the quadratic trinomial. If we were to graph this on a coordinate plane with, instead of is equal to 0 equal to y, we would see that this graph crosses at negative 2 and 16. Just another graphical representation of that. Let's look at another one here. What are the roots of x plus 24x, x squared plus 24x equal 14x. Now, for this to work right, we need to get everything to one side. So what we're going to do is actually subtract 14x from both sides of the equation. And get equal to 0. That way. Now we have like terms to combine here. We can combine the 24x and the 14x to get x squared plus 10x equals 0. Now yeah, this is a quadratic binomial. We don't need to do the factoring in the way we did the previous problem. We're just going to factor out an x from the x squared and the 10x. X squared divided by x is x, 10x divided by x is 10. So notice the factored form of this is x times x plus 10. Think of it as two equations where x could equal 0 to make the equation true, or x plus 10 could equal 0. Solving that for x, we find x to equal negative 10. Alright, so our two roots are x equals 0 and x equals negative 10. That one works just a little bit differently. Alright, and again, what are the zeros of f of x equals x squared plus 9x plus 20? Think of that f of x as y if you want, and you certainly could graph on an xy plane and use Desmos to do that. But what we're going to do is just simply put a 0 in for the f of x quantity, and then we have x squared plus 9x plus 20. Writing this in factored form, we ask ourselves, what factors of 20 add up to 9? And we would say, we'll put an x here and an x here, we'd say 4 and 5 do the trick. 5 times 4 is 20, 5 plus 4 is 9. And then we're solving these two equations by setting them equal to 0. X plus 5 equals 0. X plus 4 equals 0. X equals negative 5. X equals negative 4. Those are the zeros, and we call them zeros because when talking graphically, if we were to graph f of x equals x squared plus 9x plus 20, and you can certainly do this on desmos.com/calculator, the graph would intercept the x-axis at these two places, negative 5 and negative 4. Hence the name zeros. Let's look at another one here. What are the zeros of x squared minus 16x plus 48? I'm going to rewrite the equation. Put a 0 instead of the f of x. And we're going to ask, well, what factors of 48 add up to negative 16? Well, turns out negative 12 and negative 4 do. Think about it. If I do negative 4 times negative 12, I get a positive 48. If I do negative 12 plus negative 4, I get negative 16. We have two equations to solve for x. X minus 4 equals 0. And x minus 12 equals 0. X equals 4 and x equals 12. Two zeros. It's also where the graph of this function crosses the x-axis. And think about it, the x-intercepts, our y-coordinates, that's where the y-coordinates are always 0 on a graph. Alright, we got one more here. What are the zeros of, this time we're changing up the variables, h of w equals w squared plus 13w plus 42. No, not the xy axis as we know it, but fundamentally it works the same. We'll set up the factored form here. And we ask what factors of 42 add up to 13. That would be 6 and 7. 6 times 7 is 42, but 6 plus 7 equals 13. And that gives us our two expressions. We have w plus 6 equals 0, w plus 7 equals 0. W equals negative 6, W equals negative 7. Those are our two zeros. If we were to graph this on a similar xy plane, that's where it would cross the x-axis, or in this case, the w-axis. Alright, thanks for watching. Hope this video helped.